In our today's class, we'll be looking at the 5 angle rules. There are 5 simple rules that govern angles. And now, one of that rules is this, that the angles in a triangle add up to 180 degrees. Now, we are going to give the diagram of a right angle of a triangle. Sorry. If this is here, we have an angle A, we have an angle B, we have an angle C. Now, what this statement means is that A plus B plus C is equal to 180 degrees. Angles in a triangle add up to 180 degrees. We are going to show how this is possible when we look into the parallel lines. But this is the first angle rule which you need to take note of. That angles in a triangle add up to 180 degrees. Secondly, the second item there is that angles on a straight line add up to 180 degrees. What do we mean by that? Consider this to be a straight line, and we have an angle here, we have an angle here. This is an angle, let us call it A. This is an angle, let us call it B. This angle, let us call it C. What this thing means is that A plus B plus C is equal to 180 degrees. This is what this thing is talking about. The third one under this angle rules states that angles in a quadrilateral add up to 360 degrees. Angles in a quadrilateral add up to 360 degrees. You know what you mean by a quadrilateral? A quadrilateral is a plane shape that has 4 sides. Now, let's say that you draw any kind of quadrilateral here. You know, this is either trapezium, anything you can call it. The fact it has 4 sides. Now, this is our A, this is B, this is C, and this is D. Now, what this thing means is that A plus B plus C plus D is equal to 360 degrees. Now, the reason for this is because in a quadrilateral, we have 2 triangles. Now, let us divide this into 2. We have 2 triangles in quadrilateral. Assuming we divide our shape into 2 like this. Now, this side, the upper side gives us the sum of interior angles to be 180, and down part gives us 180. So the 180 degrees is up there. Now we have that the sum of the interior angles is equal to 180 plus 180 to give us 360 degrees. That's the sum of angles in a quadrilateral. The fourth one says that angles round a point add up to 360.
Uncle, I'm still copying number 3.
Now we have this. If this is a point, no matter the number of angles you may have there, this is A, B, C, D, E. So when you sum all these, A plus B plus C plus D plus E, you are going to get 360 degrees. That is what this is talking about. The angles around a point add up to 360 degrees. The fifth angle rule talks about isosceles triangles. Number 5, we have that isosceles triangles have two sides the same and then two angles. Now note something about isosceles triangles, that they have two sides equal and also the two angles the same. Now, if we happen to draw an isosceles triangle like this, now we mark these things. This mark you are seeing here shows that the angle here is equal to angle here. We said here that these lines, they do what? They indicate that what? The sides are equal. And now these angles, are same. They are the same. So these are the things you need to note in isosceles triangles. Two sides are equal and the two angles are equal. Now, these two angles, we normally call them the base angles. They are always there. Most times you can title this, you can turn it, and the angles will be face up. But one thing you need to note that, if these are actually same, once you see these dashes here, you know that the angles that they lead to are equal. This is the last angle rule which you need to take note of. On that isosceles triangle, let us give an example to explain more what we mean. If you have something like this, a triangle like this, and a dash was marked on points like this, and you say that here is 30 degrees, that you should find x. You have to find x. What do? You know that what, from what we have said before, this angle here is same thing as this angle here. So we have to only take away 30 from 180. Now say 180 degrees minus 30 degrees, which gives us 150 degrees. Now 150 degrees is for these two. Then you are going to what? Divide. You say 2x is equal to 150 degrees. Divide both sides by 2. This goes to this one. X will now be equal to 75 degrees. So this one angle here is 75 degrees. This angle here is 75 degrees. That is how you solve questions pertaining to right angled triangles. Given the classwork, find the size of the marked angle below. We would like you to send in your answers to us. Find the value of x in that question. What do we do? Now we know that in this question, if this and these lines are equal, it means that this angle is equal to this angle. So here is equal to what? 70 degrees. Now, we now know that in our second rule, that sum of angles on a straight line add up to what? That the angles on a straight line add up to 180 degrees. What we mean by that is that 72 degrees, which is this thing, plus s is equal to 180 degrees. You said it, angles on the straight line add up to 180 degrees. Now x will now be equal to 180 degrees minus 72 degrees. So what we have here will be 108 degrees. This is the value of s. In solving this problem, you recall that it is only in isosceles triangle that what you have what you can be given one angle and you will be able to find the rest. Now, having noted that this is an isosceles triangle, you note also that since this angle is 50 degrees and you have this back side, you have this back side here is also what 50 degrees. Now, to find this one, what we have is 50 degrees plus 50 degrees plus y is equal to 180 degrees. Our reason is because the sum of angles in the distance in the triangle is 180. So this is 100 already plus y equal to 180 degrees. Y will now be this 100 we move to this side. It will now be 180 degrees minus 100 degrees to give us 80 degrees. That is why the value of y is 80 degrees. Parallel lines, they are lines that will maintain the same distance apart. Parallel lines maintain the same distance apart. They are always
you get 44.
Note this statement. They are always the same distance apart. Now, look at what you mean by that. If you have this line, these are parallel lines. Once they continue to maintain the same distance, the distance here continues to be. If you extend this thing, extend this, they continue to maintain the same distance. So that's what we mean by parallel lines. Now we're going to now look at what? Angles that what are formed around parallel lines. Now having known this, there's what we call a transversal. A transversal is a line that crosses across a parallel or non-parallel line. Any line that let's consider parallel lines now. A line that crosses across parallel lines is called a transversal. This is what we call a transversal. Transversal cuts across parallel line. It cuts across Now, having noted this, there are some angles that are formed on these parallel lines. Now, there is like the shape of a Z. Look at this angle. It's the shape of a Z. There is also an angle that is in the shape of a C. There's what we call a C angle. Look at this angle. It's the shape of a C. And also, there are angles that are in shape of an F. We also have angle that is in shape of an F. Like in this case, we have here. These are different kinds of angles we can get around parallel lines. Let's take them one after the other. Some things here. You see, given this now, you see, from this one which we have here, we have filled in all these what spaces now. All these things came out from the kinds of angles we can get around what parallel lines. Now, these two angles, see this one now. Even this one, or let's just take this one down here. You see, once we have this type of angle, we say these angles are vertically opposite angles. Now, the first one we are noting here is what vertically opposite angles. They are formed when lines intersect each other. When they cross each other, see, this one is 40, this one is 40. Even if we are not giving this one, so far as these are intersecting lines, they cross each other. The angle here is equal to the angle here. You are seeing here also that the angle here is equal to the angle here. These are what we call vertically opposite angles. Now let's look again into another form of this. Now let's look at alternate angles. Now, alternate angles have the shape of a Z. From that, our parallel lines, alternate angles have the shape of what? Z. Once you see any angle like this angle here is equal to angle here. So if you come here A, you must come here A. That you see in this form Z is what's called an alternate, or they are called alternate angles. Now we don't have that here. Our right top here, alternate angles are the same. See, alternate angles are the same. They are found in shape. So we don't have that what? Any Z-shaped angle is called alternate angle. Or any Z-shaped angles, they are called what? Alternate what? Angles there. So remember that this line continues. It's just like our line. This is a transversal, remember? So the lines continue. The next one we'll be looking into is what we call the allied angles. Allied angles. Now we know that if this is our these are our parallel lines, and this is a transversal. Now let's just take it that we just cut off this a bit. Now you see that this looks like a C. This angle looks like a C. We have an angle here B, and they are not the same of the same side. They are not of the same size. So let's quickly take this one with another ink. We have this one as our A. Now, one thing you need to know concerning allied angles is that allied angles add up to 180 degrees. Allied angles add up to 180 degrees. You can say that well, they are supplementary. They are supplementary. Now remember, supplementary angles are angles that add up to 180 degrees. And they are formed in a C or U shape. So take note of this. Allied angles add up to 180 degrees, and they are found in that form. Now, what do you have to say here? That A plus B is equal to 180 degrees. Now, the last one we are going to look into under this angle form is what we call the corresponding angles. Now, the corresponding angles. If you check in our diagram, if this is these are parallel lines, and we have something go like this. If you check the top of this point, you see the shape this thing has. It has the shape of what? An F. Here is equal to here. The color of pairing are same, so they are equal. You now see here that corresponding angles They are the same. Corresponding angles are the same, and they are found in an F shape. They are found in an F shape. Corresponding angles are found in an F shape. Find the value of x using all the above work we've done. Find the value of x. Once you are done in sending your answers in our next class, we thank you for being part of this class. God bless you. We shall meet in our next class. Thank you so much.
Amen.